This is the Yellowstone National Park. It is a national park in the western part of the United States. It is mostly in the northwest corner of Wyoming, but it also goes into Montana and Idaho. The park is known for its wildlife and geothermal features, especially the Old Faithful geyser, which is one of the most popular. In recent years, however, the park has revealed several surprises that have scientists awestruck. So what were these discoveries all about? Keep an eye out to find out. Yellowstone National Park is 3,468.4 square miles big. It has lakes, canyons, rivers, mountain ranges, and mountain ranges. Yellowstone Lake is one of the largest high-altitude lakes in North America. It is in the middle of the Yellowstone caldera, which is the continent's largest supervolcano. Yellowstone has more than half of the world's geysers and hydrothermal features. Most of Yellowstone's land is made up of lava flows and rocks made by volcanoes. The park is the most important part of the greater Yellowstone ecosystem, which is the largest ecosystem that is still mostly whole in the northern temperate zone of the Earth. So now let's get to know about the recent discoveries at Yellowstone Park. The first discovery is about the inside of the supervolcano. Researchers now know that the supervolcano in Yellowstone National Park has a lot more magma inside than they thought before. This new study will likely help us learn more about the volcano, as well as the possible dangers it could cause in the future. But the researchers are quick to point out that these results do not mean that the popular national park is about to erupt. It also doesn't mean that the volcano is more dangerous than people thought before. Experts now have a clearer picture of the supervolcano thanks to a new study. One of the study's researchers said that this new finding will help scientists learn more about what is going on in the area than they did before. The goal is to get a clearer image. Brandon Schmant, who helped write the study, says this is about getting a better picture of what's down there and what's been there for a long time. A recent Twitter post about the study and the results say that MSU researcher Min Chen's creativity and skill brought seismic wave imaging methods into sharper focus. Scientists found out more about how much molten magma is under Yellowstone's volcano because of this. The supervolcano is in the part of Yellowstone National Park that is in Wyoming. It is called the Yellowstone caldera by many. After a powerful eruption in the area many hundreds of thousands of years ago, the feature was formed. The Yellowstone caldera is a large area that looks like a bowl and is 30 to 40 miles wide. If this volcano erupted, it could change the weather for a long time. It could even keep the sun from shining for months. The new study gave us important pictures that show how much magma is under the Yellowstone volcano. Scientists in their new study say that our results show that Yellowstone's magma reservoir has significant melt at depths that fueled past eruptions. However, our study does not confirm the presence of an eruptive body or imply a future eruption. Because we don't know how melts are spread, more melt doesn't always mean more danger. But scientists want to keep an eye on the supervolcano to learn more about what might happen in the future. The next discovery is about the cataclysmic ancient supereruptions. Researchers have found two ancient supereruptions linked to the Yellowstone hotspot track. One of them was what they think was the largest and most catastrophic event in the volcanic province, according to a new study. The Yellowstone National Park geysers, mudpots, and fumaroles are powered by a hotspot. A study published in Geology, the peer-reviewed journal of the Geological Society of America, says that between 12 million and 8 million years ago, two large volcanic eruptions shook what is now Idaho and Nevada. These eruptions were linked to the hotspot. The first supereruption, called the McMullen Creek supereruption, affected nearly 4,600 square miles of modern-day Idaho. The second, called the Gray's Landing supereruption, affected nearly 8,900 square miles of Idaho and Nevada. Thomas Knott, a volcanologist at the University of Leicester and the lead author of the paper, says that the supereruptions sent out clouds of gas and ash that were more than 900 degrees Celsius and moved at supersonic speeds, sterilizing the land surface. Knott told USA Today that the building became part of the landscape. Solid black glass would have been used to cover an area the size of the state of New Jersey. Both of the newly found supereruptions happened during the Miocene, which is the time between 23 and 5.3 million years ago. Knott said that supereruptions happened about once every 500,000 years during this time. In contrast, there have only been two supereruptions in what is now Yellowstone National Park in the last 3 million years. This means that they only happen once every 1.5 million years. Researchers also found that the ancient supereruptions were much hotter and more powerful than many other Yellowstone eruptions. Knott also said, "We think that the clear drops in temperature, size, and frequency of the Yellowstone hotspot allow us to at least ask the question, is it starting to get smaller? Since about 9 million years ago, has it been going down?" Knott said that this new information makes him wonder how long volcanic hotspots last. He wonders if they have a midlife crisis where their activity slows down before they die. Researchers won't know for sure until the hotspot goes away, but Knott said it's hard to say when that might happen. Yellowstone is still going strong and doesn't seem to be going extinct, he said, but if we can learn more about the full lifespan, if you will, of a supervolcanic province related to a hotspot, we might be able to figure out how they have changed the climate and processes of Earth over geological time. Knott said that the data might also let researchers use patterns from the past to make predictions about the present, but he also said it's hard to say when Yellowstone might erupt again. Knott says that since the last super eruption was 630,000 years ago, it could be up to 900,000 years before there is another one of this size. Knott said that this estimate should not be taken as gospel, and that scientists like those at the U.S. Geological Survey need to keep an eye on the area. He said, "We don't know. It could be tomorrow, or it could be a million years from now." Knott said he wants to do more research to find out why the hotspot seems to be getting smaller. He also wants to look further back in time to see if there have been even bigger super eruptions in the past. Next is the Rainbow Hot Spring. Yellowstone National Park is full of natural wonders, but the largest hot spring may be the most interesting, and not just because of its size. The hot spring, which is called the Grand Prismatic Spring, sends out very hot water with beautiful prismatic colors from its center. Don't change your color settings. The Grand Prismatic Spring is really rainbow colored because it follows the spectrum of white light through a prism, red to blue. The spring was officially named and described for the first time by the Hayden expedition in 1871. This was the first trip paid for the federal government to explore what would become Yellowstone. Ferdinand Hayden, who was in charge of the expedition, wrote, "The colors in these prismatic springs are so bright and delicate that nothing ever made by humans could match them. When you've seen and experienced these unique ways that nature is clever, life becomes a privilege and a blessing." But what makes the hot spring look so beautiful? All of this is because the spring is home to bacteria that like heat. When hot water comes out of cracks in the Earth's surface, this is called a hot spring. Geysers erupt because there are obstacles near the surface, but water from hot springs flows freely, making a cycle of hot water rising, cooling, and falling all the time. This constant cycle makes rings of different temperatures around the center of the Grand Prismatic Spring. Very hot water bubbles up from the center and cools as it spreads out across the spring's huge surface. The water at the center of the spring, which comes from underground chambers and bubbles up 121 feet, can get as hot as 189 degrees Fahrenheit, which is too hot for most living things. Some life does manage to exist, but it's limited to organisms that feed off of inorganic chemicals like hydrogen gas. Because there isn't much life in the middle of the pool, the water looks very clear and has a beautiful deep blue color. This is because blue wavelengths are scattered, which is also why oceans and lakes look blue. But as the water spreads out and cools, it makes concentric circles of different temperatures, like a stack of Matryoshka dolls where each one represents a different temperature. And these different temperature rings are important because each one makes a very different environment where different kinds of bacteria can live. And the different kinds of bacteria are what make the spring look like a prism. Different kinds of organisms, like cyanobacteria, which get their energy from photosynthesis, live inside these rings. As you can see in the video, at the first band to the left and right of the middle. Do you see that yellow color? That's because Synechococcus, a type of cyanobacteria, lives in that temperature range when it's under a lot of stress. At 165 degrees Fahrenheit, that water is just about cool enough to live in, but bacteria do better at temperatures closer to 149 degrees Fahrenheit. But too much light also puts stress on the Synechococcus environment. Near the Grand Prismatic Spring, there are almost no trees or other forms of shade. That is a problem not just for tourists, but also for Synechococcus. You can't get away from the sun, and at Yellowstone's high elevation, the ultraviolet light from the sun's rays is very, very strong. But Synechococcus survive even though they live in water that is too open and too hot. They do this by finding the right balance of photosynthetic pigments, which are chemical compounds that reflect only certain wavelengths of visible light, giving them different colors. Chlorophyll, which we see as green, is the most important pigment for photosynthesis. But carotenoids, which are an extra pigment, can sometimes be stronger than chlorophyll. Carotenoids can be red, orange, or yellow. The yellow pigment in Synechococcus is the same beta-carotene that makes carrots orange when it is in high concentrations. Carotenoids protect Synechococcus cells from harsh sunlight by absorbing harsh wavelengths like ultraviolet and sending that energy to chlorophyll pigments, which then turn light energy into chemical energy. So because the Synechococcus in the yellow temperature band lives in harsh conditions, it makes more carotenoids than it would if it lived in ideal temperatures, like in the outer rings. This is what gives the yellow color to the band. If you took a small amount of Synechococcus from the top of that temperature band, or found Synechococcus living in a place with less direct sunlight, it would look more like the blue-green algae we usually see in lakes and ponds. Since Synechococcus's color depends so much on sunlight, when the sun isn't as strong in the winter, the bacteria make fewer carotenoids and look less yellow and more blue-green. As you move away from the yellow band, the hot spring temperature starts to drop, and as the temperature drops, more kinds of bacteria can grow. Synechococcus still live in the orange band, which is around 149 degrees Fahrenheit, but chloroflexibacteria have moved in with them. Some chloroflexibacteria are also photosynthetic, but they get their energy from different kinds of chlorophyll and carotenoids, which makes them look a bit different. This doesn't mean that every single bacterium looks orange, but that the color of all the different colors when seen together is orange. This orange color, like the yellow in the ring next to it, comes from carotenoids, which are chemicals that these bacteria make to protect themselves from the harsh summer sun in Yellowstone. At about 131 degrees Fahrenheit, the outermost ring is the coolest and has the most diverse group of bacteria. As more organisms are able to live in the outermost ring, their different carotenoids mix to make the darkest color of all, which is reddish-brown. So if you want to witness this, then visit the Midway Geyser Basin, which is about halfway between the Madison and Old Faithful areas of Yellowstone, to see the Grand Prismatic Spring. Take the trail south from the parking lot to get to the Firehole River. The path will take you next to the hot spring, but you'll need to get up high to see the colors of the spring in their full glory. If you hike up to the Midway Bluff, you can see the Midway Basin and the hot spring below. So that was all about the video. Hope you find it informative. Then do subscribe to our channel, hit the like button, and press the bell icon for more updates like this.